So section 3.6 is the last section of chapter 3. It is all about solving quadratic inequalities. So this is all about quadratic. I'm going to erase that and rewrite it. It is all about quadratic inequalities. So that means we know how to solve every single part of this section. We just have to apply it individually. We know how to solve quadratics and we know how to solve inequalities. We know what inequalities are because inequalities are just greater than, less than symbols. But we just need to be able to plug those in and be able to solve them however they're asking us to solve them. The one that we're going to talk about specifically today is about graphing. So one quick tip that I want to give you. I am not going to take your calculator away from you, nor could I because you're learning at home. Since I am not taking your calculator away from you, what I would very strongly suggest to you is that you use your calculator to help you graph things, okay? You are going to use your calculator. You are going to have it help you graph things, which is going to save you an enormous amount of time, okay? There are really two parts to graphing inequalities that we need to be able to understand. If it gives us an equation, so if it tells us it wants us to solve the inequality, and that inequality is y is greater than or equal to x squared plus 2x minus 8. So if my inequality looks like this, there's two things that you have to think about. Actually, really three things you have to think about. Step one is to graph this thing. And graphing should be really easy because you pull out your calculator, you hit the equals button or you y equals button, and then you graph it. That should be easy. The second thing that you have to think about is whether or not to put a dotted or solid line. So you need to either put a dotted or a solid line. If the symbol is greater than or less than, it's going to be dotted. If the symbol is greater than or equal to or less than or equal to, it's going to be solid. And then finally, the last thing that you have to think about is shading. So some of you might remember this from Algebra 1, because you did do this in Algebra 1 with solving systems of inequalities when you had to graph lines. Now, what you really need to think about here is, number one, the graphing part is easy. Number two, the dotted or solid part is easy because you just look at the symbol. And number three, the shading, we just have to be able to test a point. So if I'm solving this question myself, the first thing that I'm going to do if I have my graph, because I know that I'm going to have to graph this, is I have to think about what kind of questions big ideas could give me, or what kind of choices big ideas could give me. Number one, they could actually ask me to graph that. And if it actually asks me to graph it, it's going to give me a blank graph, and then it's going to ask me to put some points down and then draw my curve through those points. If you have your calculator in front of you, this should be something that you can do basically without a brain in your head. Type in the equation, plot your 3 points, move on. The other thing that big ideas could do is it could give you four of the same kind of looking picture. It could give you a picture that looks like this, where it has a parabola like that, or a parabola like that, or a parabola like that, or a parabola like that, where it's going to be solid, solid, or dotted, dotted. The only thing that's going to change is the location of the shading. So we could shade on the inside right here, or we could shade on the outside here. We could shade on the inside here, or we could shade on the outside here. There are the four answers that big ideas could give you. They could give you all of the same exact looking location on a graph, just different shading and different solid or dotted. That's what they're going to do to you. Okay, so those are the two types of questions. So what you have to do is be able to figure out how you got your answer. Once you figure out how you got your answer, you're good to go. Okay, so first things first, let's graph this. So we pull up our calculator, and on your calculator, you are going to hit the y equals button, and then you're going to graph the equation. So x squared plus 2x minus 8. And then I'm going to hit the graph button. So big idea is likely, if this is multiple choice, is going to give you this picture 4 times. But the times that it's going to give you this, or the 4 different things that it's going to do, is it's going to give you 2 solids, one with the shading inside, one with the shading outside, or it's going to give you dotted graphs with the shading inside and the shading outside. So right now, I could very easily go back to my picture and I could draw this graph. Obviously, I don't have the best drawing tools here, but I'm going to draw a picture that closely represents what I'm looking at, which that's close enough for our intents and purposes. Okay, but now what I need to do, so I've graphed it, this part's done. I need to figure out if this is dotted or solid. This is a greater than or equal to, which makes it a solid line. So I'm not even going to have to erase anything. The last thing that I have to do is I have to be able to shade it. Does anyone remember how to shade this? Does anyone remember how to find points to shade? This is a callback to Algebra 1.
Not at all. I
So-
remember absolutely none of it.
Don't you pick a coordinate inside or outside and then put it into the equation, and if it works, then that's the part you shade. If not, then you shade that there.
Exactly. So when we are testing shading, the things that we are looking for is, so for testing shading, the first thing you do is you pick a point, but that point cannot be on the parabola. So you pick a point not on the parabola. So that is step number one. Pick a point that does not show up on the parabola. So if that point should be an x comma y. You're picking an actual point. If that point works out to be true, if it makes a true statement, you shade the point. So you shade wherever the point is located. If that statement is false, you shade opposite. So we're going to show what that means in just a second. But if you pick a point that's not on the parabola, then you're going to shade wherever that is. If it works out to be true, you're going to shade the opposite if it works out to be false. What is the point that I should always try to test no matter what?
The origin.
The origin. I should always, always, always try to test this point right here, because it's going to make my life really, really easy. The only time I cannot test the origin is when my line goes through the origin. If my parabola goes through the origin, I can't test the origin. But if it doesn't go through, I'm going to test the origin. So I'm going to test the point 0, 0. So I'm going to plug that in here. 0 is greater than or equal to 0 squared plus 2 times 0 minus 8. So that's going to be 0 is greater than or equal to negative 8. Is that true or is that false?
True.
That is true, because 0 is greater than negative 8. So this is where the point is. So I'm going to shade where this point is, and I'm going to shade all the way until I get to my parabola. So I shouldn't shade outside my parabola at all. That erased the whole thing. Perfect. I shouldn't shade outside my parabola at all. I'm shading inside the parabola, and every single part inside of the parabola should be shaded. This is what the solution looks like for a system of inequalities when you're asked to solve it using graphing. Now, the way to read this, or the way to talk about this, or think about this, is any point inside the blue would work for my equation, my inequality. So if I picked the point, any random point that I wanted, no matter what, as long as it was in the blue, it would work. If I picked the point -1, +2, -1, 2, that would work here. If I picked the point -3, +5, -3, +5 would work because it's in the blue. So any point that's inside the blue would work, okay? I'm gonna give you one right now, and I want you to try it on your own to see if it works. Pay attention to the dotted and the solid, and pay attention to the shading. Your calculator will do the work for the graph. So I'm gonna give you one right now, and I want you to try it. I'll give you a few minutes to try it out, and then we'll talk about it and go through what you need to talk about and go through. So I want you to graph and solve the inequality by graphing. And so I want you to do y is greater than -x squared plus 2x plus 4. So I want you to try to solve this inequality by graphing. And once you solve this inequality by graphing, look at where the shading is and think about all of the points that would possibly work for that. So I'm going to give you probably 2 minutes. The first thing that you should do is put it into your calculator. So your calculator should be able to help you out and figure out exactly what this graph should look like. So I'm going to go to my graph, type in my calculator, -x squared plus 2x plus 4. So I know that my graph is going to look something like this, where it crosses the x-axis at 4 and it's upside down. I'm sorry, the y-axis at 4 and it's upside down. So I know that this graph is going to look something along the lines of this. Your graphs should be a little bit more exact than this. I just can't draw anything on my computer. So try to make it as exact as possible or as close as possible. But at the very least, be able to recognize and understand on big ideas whether or not the graph they're giving you is the same as the graph that you see on your calculator. Okay? So now the next thing I'm going to do is figure out whether this is dotted or solid. I can see that right here, this is a not equal to question, which means that it's going to be dotted. So I made my point dotted, or my line dotted. And then the next thing that I'm going to do is pick a point to test. So I'm going to pick any point to test, and that point that I'm going to test should obviously be 0, 0, because it is located inside of the parabola. So what I'm going to do is I'm going to take my point 0, 0 and test it. So now I get 0 is greater than 0 plus, that should be a 0, 0 plus 0 plus 4, which is 4. Is 0 greater than 4? Not everybody at once.
No.
Thank you.
Yes.
0 is
No.
Floyd. 0 is not greater than 4.
Actually, Floyd, yeah, you're right. I forgot.
0 is not greater than 4. This is where the point is. The point is inside. The answer to my question was no, it is not. So I am not going to shade the inside, which means I am going to shade the outside. So I'm going to shade the outside of my parabola. So I'm going to shade out here. So that means that everything out here is where solutions exist. So everything out here is where the solutions exist. Any point in the pink out here is a solution. So you can pick anything located out here. All right. The very last thing that can happen, and this is where we're going to stop after this last example, is we can have a system of inequalities. So far, this was just an inequality. We are going to solve a system of inequalities, which basically is just 2 problems. All you're going to do is treat each problem individually. All right. So your system of inequalities could look something like this, where we have y is greater than, y is greater than x squared minus 4. And your other one would be y is less than or equal to negative x squared plus 3x plus 5. Something like this. So again, I want you to try this. Come up with the graphs. Your first graph, or your first equation, just graph it like one problem. Your second one, graph it like another problem, and then just look to see where they overlap. If you can do the last problem, you can do this problem. All right? So I'm going to give you a second to try it out. Let me know if you have any questions. So this first one should be pretty quick and straightforward, because I know that this is just going to be the normal parabola shifted down 4 units. So 1, 2, 3, 4, somewhere down here. And then it's just going to be a parabola that opens up like this. Oh, that was good drawing. So it's going to be a parabola that opens up like that, right? Then what you have to do is you just have to determine if this is solid or dotted, which obviously it's going to be dotted because it's going to be in just a less or greater than symbol. So I've made my line dotted.
I think you should redo the right side of that.
Why?
It's bothering me
Looks
how
a little-
it's much longer than the other
okay.
side.
Is that better?
Yes, very.
All right. Very better. So then I'm going to test a point. That point is going to be 0, 0. So I'm going to test the point 0, 0, which obviously is just going to be 0 is greater than 0 minus 4, which is 0 is greater than negative 4, which we should be able to identify is a true statement. So if we can say that that is a true statement, then that means I'm just going to fill inside wherever that point is located. So I'm going to fill in that point right here. Okay. So I have everything shaded where it needs to be shaded. Then I'm going to go to my calculator because the next one isn't as easy to graph for me. So I'm going to graph my point, or my line, y equals negative x squared plus 3x plus 5. And I'm going to graph that to see what it looks like. And I can see it's almost the exact same picture as what just happened on the last one. So this one is going to be a parabola that is opening upside down. That is going to go something along the lines of this. And then it's going to go like that. So I can see that there is an overlap, that my graph crosses there and there. And now again, I just need to test the point. 0, 0 still does not exist on my graph, right? Or on my line. So since it doesn't exist, I'm going to test it again. So 0 is less than or equal to negative 0 squared plus 3 times 0 plus 5. So 0 is less than or equal to 5, which again is a true statement. And since that's a true statement, I'm going to shade underneath my parabola where the point was located. Now you can see that my program on here already shows you where the overlap is, right? So I have light blue and I have purple or pink. and it turns into a dark blue. So you can see that this is the solution. Any point that comes from this dark blue area on the inside would work for both of these equations. So any point would work for both. Obviously, 0 is a pretty good tester for that. 0 just did work for both equations, or both of the equations, and that is where my overlap is located. All right? So this is what your graph should look like. If you're confused about what the graph should look like, you can put both of them in your calculator. And you can make sure that you have the exact overlap that you're looking for. And we should be able to see pretty much the same kind of looking picture that we had here, which we do. All right? So that's something that you need to utilize. Utilize your calculator. Utilize your ability to just understand whether or not it's dashed or solid and where the shading goes. If you can do that, if you can check all 3 of those boxes, graph your calculator, recognize dotted or solid, and shade appropriately, then you have all of this done. Does anyone have any questions before I stop recording?